Okay, fine. So the last roll number which I see is 38, roll number 07. That's it, Priyansh theory. After that, I will not take anyone else roll number. Fine, for today's attendance. So anyway, we'll go to the discussion part which I was discussing. So all of you are able to see my screen?
Yes, it is visible.
Okay, fine. So, we were talking about shapes of the sphere's pipe and having discussed so much on the, design aspects. Now we should know about how the entire procedure of construction is done. And to do that, we'll be now discussing about the laying of sphere pipes. And there are a standard, protocol or methodology which is followed while laying of these sphere pipes. And this is very important part of the construction. And at the same time, being an engineer, we cannot only concentrate on the design aspect. At the same time, we'll have to see whether the design which we are doing on the piece of paper are being implemented properly in the field or not. So that is the important part, and to do that we need to understand this particular portion. And so swears are generally, laid. It is always, starting from the outfall or the, the last end towards the starting point. So from the lowest point to the highest point, this is the sequence which is maintained while construction of the swear pipes. You need to understand this. If you do in reverse order, then it's a mistake. You cannot end up having a very good swell lines with the desired gradient which we want. Now, with this advantage of utilization of the tail swears, even during the initial periods of its construction, is possible. So that is very true. If you start from the end, you have all the flexibility to maintain, and you have a lot of flexibilities to play with the gradient, at the same time to play with the discharge, or if there is a certain gradient change, how to accommodate that. Those things can be done. Now, it's a common practice to first locate the points where manholes are required to be constructed as per the drawing. So, there are certain areas where manholes has to be constructed, and when we discuss about the in the appurtenances, we'll discuss in detail about the purpose of manholes and all. But now, right now, we consider them as an important appurtenances which needs to be constructed. Now, once you construct, or once you point out two different positions of the manholes, subsequent manholes, then accordingly you can actually lay the sphere in the intermediate area connecting from one manhole to the another manhole, from the lower manhole to the upper manhole. This is the way basically these sphere pipelines are laid. Fine. So this is as per the drawing. So that is L section of the sphere, and then laying the sphere pipe straight between the two manholes. So that is what actually I mentioned. Next is the central line of sphere is marked on the ground. Obviously, you need to do that, and then an offset line is also marked parallel to the central line at suitable distance, about half the trench width plus 0.6 meters. So this is the roughly you can take, and in most of the time it is practiced in our country. So this line can be drawn by fixing the pegs at 15-meter intervals. So the entire alignment has to be done in the beginning itself, and then it can be used for finding out center line of the sphere simply by offsetting. So this part is quite familiar to all of you, since you have already done this field survey, uh, I guess. So I guess you are able to connect which I am telling. Next is the trench of suitable width is excavated between the two manholes. This is also very important, because you need to know that what would be the diameter of your spheres, and accordingly we'll have to dig out a trench, and for that we need suitable trench, suitable width for the trench, and which is required based on the sphere width or sphere diameter, we would say. That has to be excavated between two manholes, and then the sphere is laid between them. Further excavation is then carried out for laying the pipes between the next consecutive manholes, and you basically keep on continuing this up to the highest point. Thus, the process is continued till the entire spheres are laid out. So this is the entire sequence which I wanted to mention. Now let us talk about the width of the trench and its specification. So the width of the trench at the bottom is generally kept as 15 centimeter more than the diameter of the square pipe. As I mentioned, that the trench width is completely dependent on the the diameter of the pipe, and it has to be 15 centimeter more than the diameter of the pipe always, and with a minimum of 60 centimeter width to facilitate joining of pipes. So this is also another very important part. So both the things you need to take your mind: diameter plus 15 and 60 centimeters. So whichever is you have to keep minimum 60, and if whichever is more, you need to adopt that as far as trench width is concerned. Now, if the square pipes are not to be embedded in the concrete, fine, and such as for firm grounds, when you have native grounds which is very very firm, then the bottom half portion of the trench is excavated to confirm the shape of the pipe itself, or in other word, I can say, to provide a uniform support for the pipe. Now, in ordinary or softer grounds, where's a lead embedded in the concrete always, but you may encounter ground which are firm enough to take the load of the pipe as well as the sphere which will be swage which will be carried by those pipes. Now, if you encounter such kind of ground, in that case, what you need to keep in your mind is that in case of concrete, what we do is we just simply lead when the concrete is not fixed or not set up. So during that time, the impression creates are exactly that can ensure uniform support for that pipe. However, when you have farm ground, you have to carve that ground accordingly, so that you get it can provide the maximum support for the pipe. So same kind of not trench, but the half of the pipe has to be rested on the farm ground. So this is the procedure which needs to be kept in the mind. Fine. The trench is excavated up to a level of bottom embedding concrete, or up to the invert level of the square pipe plus pipe thickness, if no embedding concrete is provided. So this is another one important point which needs to be remembered. The designed invert levels and desired slope as per the longitudinal section of the swales would be precisely transferred to the trench bottom. So this is also very important, for the smooth conveyance of the swage. Now, after bedding concrete is laid in the required alignments and levels, the sware pipes are then lowered. Fine, sware pipes are then lowered, and so basically, if you see what is done is you just, as I mentioned in the previous points also. So what you do is you just simply first put the concretes, and immediately you keep the square pipes in the in the trench, and then you do this process either by manually by the help of human power, or by use of machines if you have a bigger diameter pipe. And then once you keep that pipe, immediately that impression is created in the concrete itself, and that can ensure the uniform support which I was mentioning before. Now the square pipe lengths are usually laid from the lowest point with their socket facing up the gradient on desired bedding, and by doing this we can reduce or minimize the chance of leakage. So this is a very important part you need to remember. When if we discuss about the pipe joints, we'll talk about there in details, but here you should remember the directions of the sockets. So always remember that the lowest point with their sockets facing up the gradient, and sockets are facing up the gradient on desired bedding. So that is the way the chances of leakage is less. If the socket face uh, would have been towards the bottom end, then the chances would have been, the leakage chance would have been much more. So to avoid that, always socket facings are kept upward, towards upward, in the gradient, in any desired plane where you are actually connecting two pipes together and you are creating the joints. Now, thus, the spigot end of a new pipe can easily be inserted on the socket end of the already laid pipe. So, this is also very important. So, spigot end of a new pipe can be easily inserted. So, when you are taking a new pipe, so that has to be so the pipe will have one side spigot end, another one side smooth end. Now, this smooth end will directly go to the previously laid pipe, and then it will get attached, and then other part will be in the higher side. Next, again you take the next pipe, so that will come to the, for that particular pipe, that will come to the lower end, the smooth face of the pipe, or the smooth end of the pipe, and the spigot end of the pipe will go again in the higher side of that particular pipe, or the higher side of that gradient. So this is the way the entire, this is a process or procedure, I would say, by which, the pipe is, or sphere pipe is laid in the ground. A couple of years back, actually, when I was teaching this paper, if you have seen, anyway, if people cannot see it, or uh, we have this civil engineering building, and then we have this lab building you have seen, and then the ground which is actually existing in between. So there was a sewage line which was laid couple of years back. So for those batch of student, I just gave a live demonstration of the entire procedure, because it was quite clear, and from starting from the end, everything was done during that semester, so I could give a very good live demonstration. But right now you can't see anything, you only see those manholes and joints face, and the rest are actually under the ground. So anyway, just try to imagine the entire process and sequence. Then in the exam, if you have this kind of questions, you need not to study even. Just you need to understand the entire procedure like a story, and you will be able to write by yourself. So keep that strategy in your mind and try to understand from the beginning how this entire procedure is conducted. Next comes the hydraulic testings of spheres. So this is very important. Hydraulic testings of spheres. By doing this, we can ensure that there are basically hydraulic testings or testings of spheres. So there are many things we can see here. Another one is watertight joints. Whether the joints which this particular sphere consists of are watertight or not. So we can ensure that by doing these testings. Next is whether they are in proper, in alignment or straightness or not. That part is also can be understood by doing this test. So if you see, in case of test for leakage, that is called as water test. So how is it performed? Now the spheres are tested so as to ensure that no leakage through their joints after giving a sufficient time to those joints to set in. So immediately this test is not done, but then when we can assure that all the joints have set in, then only this particular test can be conducted, because now you are considering that particular sewage system to be ready for use. So for this purpose, the sewer pipe sections are tested between manhole to manhole under a test pressure of about 1.5 meter of water. So remember this, what actually we are testing is one manhole to another manhole. So segment wise testing is conducted. So what is done is, to carry out this, the downstream end of the sphere is plugged, and water is filled in the manhole at the upper end. Fine. Now the depth of the water in the manhole is maintained at 1.5 meter, or the head is basically maintained. Now the sewer line is inspected, and then joints which leak are repaired. Now the thing is, what is done is, you need to give some time, and you need to watch uh, thoroughly through the trench, and then if you see that there are a few joints which are leaking, you will be able to understand from the leakage, or from the wet impression which is created, and from the sweating, and immediately you repair those particular joints. And the leaking of pipes, if any, also exist after that, then that particular pipe has to be replaced. So that thing should be done here in this point itself. Now next comes the test for straightness of alignment and obstruction. So basically the test for straightness of alignments, because you see, if you don't have the straightness, then there will be higher chance of leakage. So the straightness of the sphere pipe can be tested by placing the mirror at one end of the sphere line and a lamp at the other end. Now, if the pipeline is straight, the full circle of the light will be observed. However, if the pipeline is not straight, this would be apparent, and the mirror will also indicate any obstruction in the pipe barrel. And by doing this, you can test both for straightness as well as obstruction. So any obstruction present in the pipe can also be tested by inserting at the upper end of the sphere, and a smooth ball of diameter 13 mm less than the internal diameter of the sphere pipe. So fine. So if you have a smooth ball, fine, and if you insert that in the upper end, so it will directly roll to the bottom end. And if it does not happen, that means there are some obstruction which are existing within the pipe, and that has to be taken care of by. Now in the absence of any obstruction, what will happen is, so sometimes what happens is your motor is projecting in the joints, and so those things are fine, but obstruction, those things cannot stop those balls. So the balls shall roll down the invert of the sphere pipe and emerge at the lower end. However, if there is obstruction which is not essentially the projection of motor through joints or any other plastics which have still attached, so in those kind of situation, that cannot resist the ball to roll down. So by doing this test, you can ensure, in one way you can ensure that the alignment is straight. In another way, you can ensure that there are no obstruction present. So the moment you start conveying sewage, it will run smoothly. Next, the final one is the backfilling of the trenches. So this is also an important part which has to be done once you ensure that the entire sewage network is working fine. So after the sewage line has laid and tested, the trenches are backfilled, and while backfilling the excavated earth in the trench, the earth should be laid equally on the other side of the sewers. Otherwise, what will happen is there will be a difference in the pressure, lateral pressure, which can create some problem in the sewer pipes. So, and that earth should be filled up in a layers about 15 centimeter in thickness. Each layer should be properly watered, tamped and rammed to achieve the uniform density throughout. However, the earth filling above the crown of the sewer pipes should be carefully carried out by hand, shoveling in layers and using selected soils. Usually, soft earth without any stone, rubbish, or old lumbers are used, because what will happen is, just if you apply your common sense, you will understand the most important part is the crown of the pipe. So crown is basically the top portion of the pipe. So if you end up ramming hard on the top sections, so then the top sections can collapse, and if that happens, then it's a real problem. So basically you cannot keep it in that way. So there is a chance of contamination, there is a chance of clogging. So many things can happen because of that, and that is why it is done with a lot of care and sincerity, and special type of soils are used, because if you have stone or rubbish or old number type material, then the moment you start compacting from the top, even if you don't apply huge stress or pressure, but because of those stones or rubbish, the stress concentration would be higher in certain points, and that can also create some damage to the crown of the spheres. And to avoid such kind of things, we need to be very, very careful and mindful. Now after a few months of exposure, when this top layer gets fully settled, the road pavements may be constructed or for any other purpose, and this will prevent their subsidence and cracking as well in the future. So this is the entire procedure of the what I would say, the laying of pipe, taking care of pipe, testing of pipe, and backfilling of pipe that will be used as wear systems. So hope all of you have understood this sequence. If you have any questions, I'm there to answer. Now we'll go to the next important part. So as I have mentioned several times that appurtenances. So in this particular mm, section, we will be discussing about the appurtenances of the spheres, or in other words, we can say sphere appurtenances. So basically, what is sphere appurtenances? So sphere appurtenances are those structures which are constructed at suitable intervals along a sphericity system and help in its efficient operation and maintenance. So basically, these are known as appurtenances. And if I have to enlist appurtenances, the first and the foremost one is obviously manhole. I have already mentioned about manholes in the previous sections. Next is drop manholes. Next is lamp holes. Fine. Next is cleanouts, street inlets called gullies, then catch basins, flushing tanks, grease and oil traps, inverted siphons, and storm regulators. These are the devices which are used, in most of the sewage system, just to have smooth operation and maintenance of the sewage system. Now we'll discuss one by one in detail about them. So let us go to the next slide. So the first one is the manhole. So if I have to define the manhole, so manhole is a masonry or RCC chamber constructed at suitable intervals along the sewer lines for providing access into them. Thus, the manhole helps in inspection, cleaning, and maintenance of sewer. So you should have sufficient space, beneath the ground surface where you can stand and you can work on the pipelines, and at the same time you can ensure cleaning, proper maintenance of the pipelines standing on that platform. So this is the you can see here sectional elevation of the manhole which I have shown over here. And this manhole, it basically consist of several components which I have shown over here. You can see that. So we have from the bottom, if we see within the manhole, we have, this is a chamber as I have already mentioned, so which is made up of RCC or brick masonry. So we have a bottom base slab, and on the top of the base slab you will have your this pipe which will be resting. You have a benches, and benches will have certain slope, so that if there is a water or any liquid, any part of that manhole, so it will come and converge into the uh, towards the flow channel. Then you will have steps, so to reach to the bottom of the mm, manhole. And then you have a cone surface at the top, just in order to reduce the mouth of the manhole. And then you have braid rings, and finally the cover and the frame. And this cover and the frame is exposed most of the time. And if you visit in the town or in the cities, you will see a lot of circular gap in the in the pavements or in the road. So those are nothing but the cover of the manhole. So you have cover and frame at the top, and this is the different components of a manhole. Now, apart from whatever I have discussed, are manholes has another one very important role in proper maintenance of the sphere pipes. Sometimes what happens is some toxic gas, which are very pungent in nature, are produced within the sphere pipes. Now, most of the time, you will see that these manhole covers are this will have some slit into it, or this will have some void into it, so as to having proper ventilation of the manholes. And by doing this, you can ensure that whatever toxic gases are generated in the storage system will be diffused through these ventilators, and then they will actually get diffused in the atmosphere, and thereby the toxicity reduces since its concentration reduces. And when you access the manhole, by the time there are no, I mean, no significant concentration of toxic gases exist within the manhole. So this is another one important role of manhole. Now, as far as locations and spacing are concerned of the manhole, so we need to see few things, and manholes are actually depends upon the spacings and several factors. We'll be discussing them. So manholes are generally provided at regular intervals in straight sware line, and also at points of every vein junction change of gradient and as well as change of sware dia. Unless there are practical difficulties, the sware line between two manholes is laid straight with even gradient. This part we have mentioned while talking about the laying of sware pipes. Now, even when the sware lines run straight, the manholes are provided at regular interval. That is required. Why that is required, I have already mentioned, and you can relate with that. So the spacing between the manholes in such case, however, depends mainly upon the size of the sware line. Fine. The larger the diameter of the sphere, the greater will be the spacing between the manholes. And the manholes spacing generally adopted on state spheres are given in this particular table. You can see so spacing of manholes for the straight alignments. So up to 0.3 meter dia of the sphere, we have 45 meters of spacing, and subsequently with increase in the diameter you have spacing which is also increasing, and then finally for 1.5 meter dia sphere pipes, which is very unusual, and for that you have 300 meter gap or spacing between subsequent manholes. This is what a spacing allowance of 100 meter per 1 meter dia of sphere is general rule in case of very large spheres. So suppose you are actually working with dia which is more than 1.5 meter. So in that case, you can follow these rules. So basically, spacing allowance for 100 meter per 1 meter dia of the sphere, and accordingly you can finalize the interval which you want. Now, apart from this, we have the minimum internal dimensions for manhole chambers. So that the dimensions also are very important within the manholes, and we have to see that on what I mean, like what would be the maximum internal dimensions of a manhole, and on what parameters does it depend upon. So with depth of spheres, accordingly we actually maintain the internal dimensions of a manhole chamber. So for zero point 0.8 meter or less depth, we have a 0.75 by 0.75 meter manhole. Now once this depth is increased from 0.8 meter to 2.1 meter, so this is a significant depth, you need a higher area. So 1.2 meter to 0.9 meter, and for depth above 2.1 meter to 9 meter, we have either 1.2 meter and 0.9 meter, which is similar to the previous conditions. Or in case of circular, it has to have a diameter of 1.4 meter. Subsequently, if you have a depth of swarage line of 9 meter to 14 meter, in that case 1.8 meter dia circular uh, manholes are constructed. Now the minimum width of the manhole should not be less than internal diameter of the sphere pipe plus 150 mm benching on both the sides. So the benching means you can go back to the previous this part, and you can see so the diameter, fine. So the internal diameter of the sphere pipes, so the internal diameter, hope all of you are able to see my mouse point, and then plus 150 mm benching on both the sides, here 150 mm and here 150 mm benching diameter plus this that would be the minimum of a manhole, regardless of depth. So if you are actually keeping the sphere pipes less than 0.3 meter, but then your diameter is more, in that case you have to go by the the final provisions which we discussed over here. You cannot take the value directly which is mentioned in the previous tables. You have to take the minimum internal diameter plus 150 mm benching in both the sides, so 150 mm into 2 plus the sway dia, that would be the overall width for that kind of situation. Hope all of you have understood. So there are different type of manholes. So let us discuss. See, manholes is the most important, as I mentioned before. So we'll be discussing them in detail. So a shallow manhole is basically, from the name itself, you can see that depending upon the situations and the distance from the ground surface, we can classify them in three different classes. The first one is shallow manholes. So in this case, the manhole is about zero 0.7 to zero 0.9 meter in depth and is constructed at the start of a branch sphere or at places which are not subjected to heavy traffic. Because see, we are talking about shallow, so we don't have enough soil cover at the top. So that is why if we apply huge load like traffic load, then that can damage the sphere pipes. And in order to avoid that, we can only adopt shallow manhole and shallow sphere pipes where we don't have the chance of heavy traffic which can come within the zone of the manhole. So such a manhole is provided with a light cover at its top and is called as an inspection chamber. So these shallow manholes are often called as inspection chamber. See, the components within the manhole will remain as what we discussed in the previous case, just based on the depth of construction. Few things would change, and that is what we are talking about. So shallow manholes are often called as inspection chamber. Now the normal manholes. So normal manholes are basically known as medium manholes. So in this case, 1.5 meter is the depth of construction, and they are either in square shape 1 meter by 1 meter or in rectangular shape 1.2 meter by 1 meter in cross section, and its section is not changed with depth as is done in a deep manhole. So in this case, if you see the first figure which I showed you sometimes back, here the depth, the diameter is changing. However, in this case, means in case of inspection chamber and in case of medium manholes, the diameter is not changing. It's the section is same regardless of the depth. So this is an important part and should be remembered. And such a manhole is provided with a heavy cover at its top. So you can use heavy covers, and then so there is no restriction. It can be constructed anywhere. Next, the important one is the deep manholes. So deep manholes, there can be different type of deep manholes. One I have shown you before. You can have other two type of deep manholes which have been shown in this particular slides. And in this case, you need to know that the depth would be 1.5 meter, and or minimum is 1.5 meter or more. So once it is more, we say that this is a deep manhole. The section of such a manhole is generally not kept the same. The size in the upper portion is reduced by providing an offset, which you can see from these particular figures. Steps, etc., are provided in such a manhole for facilitating descending into the manhole and to enable the workers to go up to the bottom of the manhole chamber. Now, such a manhole is provided with a heavy cover at its top, and that is very obvious. And if we don't provide heavy cover, it is difficult because such a huge void is there beneath that particular cover. So that is why heavy covers are always provided in case of deep manholes. And they can actually support the traffic load. So remember these different three types of manhole. Now, apart from these, we have another two types of manholes. So these are not, based on depth, but we have some other different type of manholes. Let us discuss them. So we have straight through manholes. Now this is the simplest type of manholes which is built on straight run of sphere with no side junctions. So where there is change in the size of sphere, the soffit or crown level of the two spheres would be the same, except where special conditions require otherwise. So this is very important to remember. So straight through manholes are provided when you need only to change the diameter of the pipe, and there is no provision of connecting any other spheres coming from lateral direction. So there is no provision of side junctions. However, when there is a change in the size of the sphere, the soffit or crown level of the two spheres should be the same. This is also very important to remember. If you don't do that, then there will be a disturbance in the flow of the switch. So the crown is always in the same level. However, so the top may change, and in between these two diameter, you will have the manhole, and that manhole is known as straight through manholes. So the purpose is only to change the diameter. Next is junctions manholes. So in this case, the type of manholes are constructed at every junctions of two or more spheres and on the curved portion of the spheres. So their purpose is just to connect. That is why we say junction. So two or more sewer pipes converge into one junction manholes, and this type of manholes can be constructed with the shape or other than rectangular to suit the curvy requirement and to achieve economy. So since the direction are not fixed, it can come in at any angle. So that is why if you construct a circular one, that would be most economical, and keeping that in mind, in this case the rectangular sections are avoided. In case of junction manholes, mostly circular sections are preferred. Right? Now the soffit of the smaller sphere at junction should not be lower than that of the larger sphere. So the gradient of the smaller sphere may be made steeper from the previous manhole to reduce the difference of invert at the point of junction to a convenient amount. So that is fine, but then you cannot change the level of the soffit. Fine. So this is also very important to remember. Next is side entrance manhole. So side entrance manhole, in case of large spheres where it is difficult to obtain direct vertical access to the sphere from the top ground level due to the obstructions such as other pipelines, water gas lines. So the access shaft should be constructed in the nearest convenient position of line of the sphere and then connected to the manhole chamber by a lateral passage. Fine. Remember this. That is why we say side entrance manhole. In this case, the entry towards the manhole is not directly from the top because of some interruption. We are unable to do that, so we'll have to create a lateral passage up to that same level, and then there will be a side entrance towards the manhole. Now the floor of the side entrance passage should fall at about 1 in 80 towards the sphere and should enter the chamber not lower than the soffit level of the sphere. So these the levels are very important, and all of you should remember, in large spheres necessary steps or a ladder should be provided to reach the benching from the side entrance above the soffit, right? So if you have a step, basically what is happening is you are coming from the side. So if your bench is at some the level of your side entrance and level of your bench is not same, in that case you need to provide some ladder or some steps to reach to the bottom. So with this, we'll stop today's class, and in next class, we'll discuss about other type of manholes and subsequent appurtenances.